In this video, we'll do trigonometric functions. This is going to be a quick review. We're not going to cover the in-depth aspects of the trigonometric functions which you will study in mathematics. We'll be covering only those aspects which is important in order to understand the fundamentals of physics. So let's get started. So the first thing that we'll learn about are the plane angles. So if you imagine any circle like this and one line in the circle like this and another line is like this. So we need to talk about what is this angle theta. Well, this angle theta is basically the ratio of the two physical quantities. What are those two physical quantities? This length, arc length, let's say it is equal to L and the radius of the circle is equal to R. Then we define this angle theta as equal to L divided by R. So this is basically our plane angle. And what is the SI unit of this plane angle? SI unit of this plane angle is radians, which is referred by RAD. So in high school, usually we measure this angle theta in degrees, but from now onwards, we'll be majorly dealing and taking this angle theta in radians, that is its SI unit. So we need to have a relation between radians and degrees. So what is this relation with degrees? Let's look at it. It is 1 radian is basically equal to 180 divided by pi degrees. So basically degree is another unit of this plane angle. In fact, we can write it over here. Not just degree is another unit. There are various other units like minutes and seconds. So we can write about the other units. So number one is degree. So it is 1 degree, which is equal to pi by 180 radians. And we have further more units, that is 1 minute. 1 minute is noted by 1 prime like this. This is equal to 1 by 60 degrees, or simply it is 1 degree equal to 60 minutes. And we have further another unit within the same set of degree system. It is 1 second, which is 1 double prime, that is equal to 1 by 60 minutes, or simply we can memorize it in this manner, that 1 minute is equal to 60 seconds. And from these two, we can actually also memorize it that 1 degree is equal to 3600 seconds. So from here, we are going to memorize few important points, that basically pi radians is equivalent to 180 degree in the other units system, and pi by 2 radian is going to become 90 degree, and pi by 3 radian is going to become 60 degree. Similarly, if we talk about a complete circle, 2 pi radian, it is going to become equal to 360 degree. Like this, we can memorize few other conversion factors. For example, if I write 3 pi by 2 radian, that is going to be equal to 270 degrees like this. So mostly we are now going to deal this angle theta in radians. So you should be knowing its conversion from radian to degree and from degrees to radians. Now the next in this would be trigonometric ratios. Consider a circle like this, and this is the x-axis and this is the y-axis. And let us analyze any point on this circle whose coordinates are x, y. That means this vertical distance from the x-axis is going to be equal to y, and its horizontal distance from the y-axis, basically this distance, is going to be equal to x. So if we join this point from the origin, let's say this distance of this arrow is equal to h, and the angle made by this radius vector, which is shown in the green color, let's say this angle made by this vector with the x-axis is theta. So as this point rotates on this circle, this angle theta is going to change. So what are the various trigonometric ratios? The first trigonometric ratio will be sine of theta. Sine of theta is basically perpendicular upon hypotenuse. That's what we have studied in our high school. So according to this circle, it is going to become y divided by h. And what is cos theta? It is based upon hypotenuse, that is x divided by h. And what is tan theta? Tan theta is going to be equal to perpendicular divided by base, which is y by x. Similarly, we have reciprocal of sine theta, which is cosec theta, that is equal to 1 by sine theta. And then we have sec theta, which is equal to 1 by cos theta. And then we have cot theta, which is equal to 1 upon tan theta. Well, these are the various trigonometric ratios that we are going to deal with in this particular topic. And in fact, if you look at this figure, this angle theta can be either in the first quadrant, or it can be in the second quadrant, or it can be in the third quadrant, or it can be in the fourth quadrant. And according to it, the x coordinate and y coordinate, it can be positive or negative depending upon in which quadrant the angle theta lies. For example, in the first quadrant, x and y, both of them are going to be positive. In the second quadrant, x is going to be negative and y is going to be positive. In the third quadrant, x is going to be negative and y is also going to be negative. And in the fourth quadrant, x will be positive and y is going to be negative. So depending upon the sign of x and y, these trigonometric ratios are going to be positive or negative depending upon the angle theta, whether it lies in the first quadrant, second quadrant, third, or the fourth quadrant. Anyways, let's now talk about the various trigonometric relations that we have. Well, we have various trigonometric relations that actually helps us in finding trigonometric ratios of angles which are more than 90 degree. Because up to high school, we know what is the value of sine 30 degree, cos 45 degree. That means that the trigonometric ratios of any angle that is in between 0 to 90 degree. But now we are going to talk about the trigonometric ratios of the angles which is more than 90 degree. Then how to find out these trigonometric relations help us in finding the trigonometric ratios of angles more than 90 degrees. So let's have a look at the various trigonometric relations. One is sine of 90 minus theta is equal to cos of theta, and vice versa is also true. So it becomes, and the next relation is, if it is tan of 90 minus theta, it is going to be equal to cot of theta. And again, the reverse is also true. If it is cot of 90 minus theta, it is going to be equal to tan of theta. Similarly, now we have, if it is sec of 90 minus theta, it is going to be equal to cosec theta. And the reverse is also true, that if it is cosec 90 minus theta, then it is going to become equal to sec of theta. So this is first set of trigonometric relation. Now the second set would be, what if the angle 90 minus theta is written as 90 plus theta? That is, the ratios are like this. Well, then sine 90 plus theta, it is going to become cos of theta. Cos 90 plus theta is going to become minus of sine theta. Tan 90 plus theta is going to become minus of cot theta. And sec 90 plus theta is going to become minus of cosec theta. And similarly, if we write cosec of 90 plus theta, it would be equal to sec of theta. Well, how we are going to memorize this relation? Well, there is a trick associated with it. Well, the trick is like this, that if the angle theta, it is in the first quadrant, then all the ratios are going to be positives, whether it is sine, cos, tan, and sec. And if you look at 90 minus, 90 minus, 90 minus, 90 minus, that means they're all in the first quadrant, and therefore all of them are positive cos theta, positive sine theta, positive cot theta, and positive cosec theta. However, in the second quadrant, only sine and its reciprocal, they are going to be positive. And therefore, if you look at sine 90 plus and cosec 90 plus, they are only positive. You see, sine 90 plus theta is plus cos theta, and cosec 90 plus theta is sec theta, and all the other ratios, they came out to be negative. And similarly, if we talk about the angle which is in the third quadrant, and in the third quadrant, tangent and its reciprocal cotangent, that means cot, tan and cot, they are going to be positive, rest everyone is going to be negative. And in the fourth quadrant, cos and its reciprocal, that is sec, they are going to be positive. All other ratios are going to be negative. So you can memorize it as all students take care or all students take coffee, whichever way is convenient to you. In this manner, you can memorize this little trick or this little rule, and in accordance to this, you can actually get whether sine 90 minus theta would be what, or cos 90 plus theta would be what. Anyways, let's now talk about further more trigonometric ratios. If it is, let's say, 180 minus theta, then how to write, and if it is 180 plus theta, then how to write. So if we talk about the ratios of angles 180 minus theta, 180 plus theta, then let's see how we are going to do it. Sine of 180 minus theta, basically 180 minus theta is going to be in the second quadrant, and in the second quadrant we know that sine and cosec, these two ratios are going to be positive. So let us make positive over here, positive over here, and sine is going to remain as sine and cosec is going to remain as cosec because it is 180. So it is going to be sine of theta, positive. And similarly here it is going to be cos of theta. So we have to memorize it that in case of 90 plus minus, sine will convert to cos, cos will convert to sine, tan will convert to cot, cot will convert to tan, sec will convert to cosec, cosec will convert to sec. However, in case of 180 plus minus, sine will remain sine, cos will remain cos, tan will remain tan, and so on. We just need to look at the sign in accordance with this all student take care rule. So applying that rule in case of 180 minus theta, we have already seen that it is in the second quadrant. Only these two ratios are going to be positive, else all the other ratios are going to be negative. So cos 180 minus theta will be cos theta, tan 180 minus theta will be tan theta, sec 180 minus theta will be sec theta. Similarly, if we apply the concept here at 180 plus theta, so first of all, we'll see 180 plus theta is in which quadrant? It is in the third quadrant, and in the third quadrant, it is the tangent and cotangent. They are going to be positive, rest all of them are going to be negative. And therefore, this is positive, and the reciprocal of tangent, cotangent, it is going to be positive, which I have not written it over here. And rest, all of them are going to be negative, 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 and negative. And we know that it is 180 plus minus. In that case, we do not change, sign remains sine, so it is sine theta. Cos 180 plus theta, cos will remain cos theta, tan will remain tan theta, and cosec will remain cosec, and sec will remain sec theta. So this is how we write the trigonometric ratios of 180 plus minus theta. Now let us talk about the trigonometric ratios of 270 plus minus theta. So if we now look at the angle 270 minus theta, we'll see that it is going to lie in the third quadrant. So in the third quadrant, tangent and cotangent, they are going to be positive only, and therefore we'll just put positive sign over here. And since we have not written the case of cot of 270 minus theta, you know what it is going to be. Rest all of them are going to be negative. So sine 270 minus theta, as I said, on 90 plus minus and 270 plus minus, sine will convert to cos, cos will convert to sine. This conversion are going to happen. So sine theta, sine will become cos of theta, and this cos will become sine of theta, this tan will become cot of theta, this sec will become cosec theta, and this cosec will become sec theta. Now let's have a look at the angle 270 plus theta. This is the fourth quadrant, and in the fourth quadrant, cos and sec, they are only positive ratios, and therefore we'll put positive sign over here and positive sign over here. Now rest all of them are negative, so let's put negative sign over everywhere. Sine will become cos theta, cos will become sine theta, tan will become cot theta, sec will become cosec theta, and cosec theta, cosec will become sec theta. So this is how we are going to do in cases of angle which is 270 plus minus. Let's now talk about the case of 360 minus theta and 360 plus theta. So clearly in 360 minus theta, the angle is lying in the fourth quadrant, and in the fourth quadrant, cos and sec, they are going to be positive. So let's put positive sign over there, and rest all of them are going to be negative. And we know that at 180 degree plus minus and 360 plus minus, there will be no change. Sine will remain sine theta, cos will remain cos theta, tan will remain tan, sec will remain sec, and cosec will remain cosec theta. Now what about 360 plus theta? Well, 360 plus is nothing but you have completed one complete circle. So it is like the square one position. We again come back to the same position. So sine is 360 degree plus theta. It is again the first quadrant. So it's very easy. It is sine theta. This is cos theta. This is tan theta. All of them are going to be positive. So this is how the angles of 360 plus minus theta are going to become for these different trigonometric ratios. And in fact, here we can also talk about what will happen to sine of minus theta. Sine of minus theta is basically sine of 0 degree minus theta, that is in the fourth quadrant, and in the fourth quadrant it is going to be minus of sine theta. And cos of minus theta is going to be, it is in the fourth quadrant, cos is going to be positive, so therefore it is cos of theta. And what is tan of minus theta? It is equal to tan of theta. And we must memorize all these relations, and you don't have to memorize them, you just need to know what are the rules and tricks, and in accordance to that rule you have to write these ratios. Now see how we are able to find the trigonometric ratios of angles more than 90 degree by using these trigonometric relations. It is quite easy. For example, if you want to find out what is the value of sine of 120 degree, well, in that case, just put this theta equal to 30 degree. So sine of 90 plus 30 is going to be equal to cos of 30. So sine 120 degree is going to become equal to cos of 30 degree, which is nothing but root 3 by 2. Similarly, if you want to find out what is the value of cos of 120 degree, so just put here theta equal to 30 degree, then you are going to get the value of cos of 120 degree. So cos 120 degree is equal to minus of sine of 30 degree, which is nothing but minus of 1 by 2. So you must memorize all these values. In fact, if you know the rule, it is really good. But if you memorize these values, sine 120 degree root 3 by 2, cos 120 degree minus 1 by 2, then it is going to help you. In fact, there are some other values which I'm going to tell you. That is, sine of 180 degree is going to be equal to 0. This is equal to tan of 180 degree. And what about the cos of 180 degree? Cos of 180 degree will be equal to minus 1. And what is cos of 90 degree? This is equal to 0. This is equal to cos of 270 degree. And what is the value of sine of 270 degree? That is 3 pi by 2. This is equal to minus of 1. Well, there are certain other facts which you can memorize. For example, we write sine of 2n pi plus theta. 2n pi, basically it is like either 2 pi or it is 4 pi or it is 6 pi, like completing one circle. It is as good as nothing has changed. So it is equal to sine of theta, and it happens not in just case of sine, it happens in case of cos as well as sec as well as tan, etc., etc. In all the ratios this is true. So this is true for all the ratios. Well, we must memorize all these values in addition to the values which we already know from the high school. What are those values which we already know from the high school? Let's have a look at that. It is the value of trigonometric ratios for the angles 0 degree, 30 degree, 45 degree, 60 and 90 degree. Let's have a quick review of it. In case of sine theta, it is going to become 0, 1 by 2, 1 by root 2, root 3 by 2, and sine 90 is 1. And in case of cos, things are going to get reversed. That means we started from 0 to 1 in case of sine. Here we have to start from 1 and ending at 0. So it's going to be 1 root 3 by 2, 1 by root 2, and 1 by 2. Now tan theta is nothing but the ratio of sine to cos, and therefore tan 0 degree is 0. It is 1 by root 3, 1 root 3, and tan 90 degree is not defined, or simply we can say that it is tending to infinite. Now what about cosec? Well, again, it is a reciprocal of sine theta, so 1 by 0 is going to be not defined, or simply it is going to tend to infinity if theta is tending to 0 degree. Cosec 30 degree will be 2, cosec 45 will be root 2, 2 by root 3, and then 1. In case of sec theta, it is a reciprocal of cos theta, so it would be 1, 2 by root 3, root 2, 2, and not defined. And in case of cot theta, it is basically the reciprocal of tan theta, and therefore it would be not defined at theta equal to 0, then root 3, 1, 1 by root 3, and cot 90 degrees 0. So we must memorize all these values if we have not. And in fact, in addition to all these values, there are two more values which you must keep in your mind, because they are going to help you in solving problems in physics. What are those two values? For that, let's focus on this special triangle. What is so special in this triangle? Let's say one of the side is 3 unit, this is 4 unit, then the hypotenuse by using Pythagoras theorem must be equal to 5 unit. So in this special triangle, this angle is approximately equal to 37 degree and this angle is approximately equal to 53 degree. So in problems, sometimes we may require the value of sine 37 degree or cos 37 degree or tan 50 degree like that. So if you keep this triangle in your mind, we can actually calculate the value of sine 37, cos 53 or whatever we need. For example, sine 37 degree is equal to, for 37 perpendicular is 3, so it's 3 by 5. Cos 37 degree will be equal to 4 divided by 5 and so on. If you want to write the value of tan of 53 degree, it is going to be perpendicular upon base. So for 53 degree, perpendicular is 4, so it's 4, base is 3, so it's 4 by 3 and so on. So we don't have to memorize each and every values. You just need to memorize this triangle in your mind. If it is there in your mind, then you can write down whatever values is needed as per the situation. So this is all about how to find out the trigonometric ratios with respect to any angle. Now let's talk about few trigonometric identities. Well, there are so many trigonometric identities, but here we are going to write only those identities which we require in physics. For example, the first set of trigonometric identities, you already know it from high school, that it is sine square theta plus cos square theta equal to 1. Second is sec square theta equal to 1 plus tan square theta and cosec square theta equal to 1 plus cot square theta. Let's talk about another set of trigonometric identity. Sine A plus B equal to sine A cos B plus cos A sine B. Second is sine A minus B equal to sine A cos B minus cos A sine B. Then we have cos of A plus B, which is equal to cos A cos B minus sine A sine B. Remind it, if it is plus over here, it has to be minus over here. And then we have cos A minus B, which is equal to cos A cos B plus sine A sine B. Again, if it is minus over here, it should be plus over here. Then we have tan of A plus B, which is equal to tan A plus tan B divided by 1 minus tan A tan B. And lastly, we have tan A minus B equal to tan A minus tan B divided by 1 plus tan A tan B. So this is the second set of trigonometric identities. Let us now talk about the third set of trigonometric identities. So this is a third set of trigonometric identity in which sine 2 theta is equal to 2 sine theta cos theta, cos 2 theta equal to cos square theta minus sine square theta, and in fact cos 2 theta are going to have three different sets of relations. That is, we can write it in terms of sine square theta only, then it becomes 1 minus 2 sine square theta, and if we convert this sine square theta in terms of cos square theta, then it is going to become 2 cos square theta minus 1. Similarly, we can talk about tan of 2 theta. In fact, in the previous identity, you can put A equal to theta, B equal to theta, then you are going to derive all these relations. So tan 2 theta is going to become 2 tan theta divided by 1 minus tan square theta. So this is the third set of trigonometric identities. Let us now talk about the fourth set of trigonometric identities. So this is the last set of trigonometric identities which we may require. The first is sine C plus sine D, which is equal to 2 times sine of C plus D by 2 cos of C minus D by 2. Similarly, sine C minus sine D will be 2 times cos C plus D by 2 sine C minus D by 2. Cos C plus cos D is equal to 2 times cos of C plus D by 2 multiplied by cos of C minus D by 2. And similarly, then finally we have cos C minus cos D is equal to 2 times sine C plus D by 2 into sine of C minus D by 2. So these four sets of trigonometric identities we must memorize, which is going to help us again in solving problems in physics. Now with this, we are going to talk about all the trigonometric ratios, the 6 ratios separately. That means the sine function, cosine function, tangent function, cosecant function, secant function, and cotangent functions individually. And the first thing that we'll start with is the sine function. So we'll start with the sine function first. Sine function is y equal to sine of x. Now what is the domain of this function? Well, all values that x can take is going to be from minus infinity to plus infinity. It can take any value. What about its range? All values that y can take, well, it will be confined between minus 1 to 1. That means the maximum value of sine x is going to be 1 and the minimum value of sine x is going to be minus of 1. Let's have a look at its graph. Well, the graph is going to look like this, y equal to sine x. You can see that the maximum value of this graph is at x equal to pi by 2, which is going to be 1, and the minimum is at x equal to minus pi by 2, which will be minus of 1. And one thing you can observe from this graph is that this graph is fluctuating in nature, or it is periodic function. Basically, it repeats itself after a regular interval of period. For example, after 0 to 2 pi, if you see, the graph is again repeating itself. Therefore, we can say that the function of sine x is a periodic function with period equal to 2 pi. Now, second thing we should write about the average value of the sine x in certain intervals. Which is going to help us in physics at many places. For example, in the interval of 0 to 2 pi, what will be the average value in the interval of 0 to pi, or in the interval of 0 to pi by 2? Let's write the average value of the sine x in all these intervals. So the average value of sine x in the interval 0 to 2 pi, as you can see from the graph, it is going to be 0 directly. We can see that because in the interval of 0 to 2 pi, you can see from 0 to pi the graph is positive, and similarly it is negative from pi to 2 pi, and therefore the on an average value of the sine x between this interval is going to be 0. However, its average value between 0 to pi is not going to be 0. So how much it is going to be? Well, it is going to be 2 by pi. How do we calculate it? Well, we do it in the chapter of integration. So right now you just need to memorize it as it is, that the average value of sine x is equal to 2 by pi. And not just in the interval of 0 to pi, in the interval of 0 to pi by 2, the average of sine x is going to be 2 by pi only. In fact, the interval of 0 to pi by 2 and in the interval of pi by 2 to pi, the average is going to be same. And the same average is going to be for the interval of 0 to pi. This is the basic arithmetic sense. And one last thing that we will observe from this graph, that as the value of x is tending to 0, that means if the angle is very small, then in that case, you can see that this graph is almost looking like a straight line. And in fact, this straight line is passing through the origin, and the slope is almost 45 degrees. And therefore, we can say that when angle is very small, then in that case, the function sine x is going to resemble the equation y equal to x. And so we can write that if x is tending to 0, then sine x will be nearly equal to x. So we are going to use this in situations where the angles involved are very small. So there we can write that sine of angle is nearly equal to that angle. Remember that the angles used over here will be in radians and not degrees. Right. So the function sine x is going to be used in physics in various situations. For example, we are going to analyze the oscillatory motion, which is going to be a periodic motion, or the motion of a wave. There, this function is going to be very useful, and these things which I have just written on the board, they are going to be very helpful. So you need to memorize all these values. Let us now talk about cosine function. So this is our cosine function. What will be its domain? All values that x can take is from minus infinity to plus infinity. That means all real numbers. What is its range? Its range is also confined between minus 1 to 1. The maximum value of cos x is going to be 1, and minimum it is going to be minus 1. Let's have a look at its graph. This is how the graph of cosine function is going to look like. Well, you can see that this graph is identical to the sine function, but with a little difference. In case of cosine function, the peak is at x equal to 0. However, in case of sine function, the peak was at x equal to pi by 2. So basically, this graph is a shifted graph by pi by 2 as compared to the sine x. Otherwise, the maximum value is going to be 1, and the minimum value is going to be minus of 1. And this graph is also a periodic graph. You can see that after an interval of 2 pi, if x is equal to 2 pi, again the cos x is going to reach at its peak value, and at x equal to pi, it is minus 1. We can memorize this fact that cos of pi, we have already written it, that cos of 180 degrees minus of 1. So we can write it over here that the cos x function is also a periodic function with a period of 2 pi. Second thing, we'll talk about the average of this cosine function in various intervals. So the average of cos x, let's say in the interval of 0 to 2 pi, you can see that in the interval of 0 to 2 pi, it is going to be 0. However, in the interval of, let's say, 0 to pi, in fact, in this interval also it is going to be 0, because if you look at from 0 to pi, the graph is positive, and from pi by 2 to pi, the graph is equally negative, and therefore the average of cos x from 0 to 2 pi as well as from 0 to pi, they are going to be 0. If you talk about the interval 0 to pi by 2, the average is going to be non-zero, and in fact in the interval of 0 to pi by 2, the average will be 2 by pi. And in fact, if you want to talk about the average of this cos x from the interval minus pi by 2 to pi by 2, again it is going to be 2 by pi. And the last thing here, if x is tending to 0, then what can we write about cos x? Then cos x can be written as nearly equal to 1. So at places we write cos x equal to 1. Sometimes we are going to write it as 1 minus x squared by 4. Well, this is a quick revision basically, so you just need to memorize these things as it is. And as I said, sine x and cos x, both these functions are going to help us in analyzing the motion of oscillatory nature and also the motion of waves. So all these things which we have written are going to help us in physics. We must memorize them as it is. Let us now talk about the tangent function. Well, the tangent function is not going to be of much help in physics, but still we'll talk few things about it. This is y equal to tan of x. What all values x can take? Well, x can take any value except those values where cos x is equal to 0. And you know what are those values where cos x is equal to 0? It is pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, and so on, plus minus obviously. So the domain of this function is any real number except 2n plus 1 pi by 2. This 2n plus 1 is basically the odd number. N is an integer, so it can be positive integer, it can be negative integer. So basically this term is nothing but plus minus pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, and so on. So this is going to be the domain of this function. Let us talk about the range of this function. Well, the range of this tan x is going to be from minus infinity to plus infinity. Now let us have a look at its graph. Well, the graph of y equal to tan x is going to look like this. At x equal to 0, it is 0, and as x approaches pi by 2, tan x is going to approach positive infinity. But if you are approaching pi by 2 from the second quadrant, then in that case tan x is going to approach negative infinity. That is very much obvious, okay, because in the second quadrant we already know, all students take care, tangent is negative, and in the third quadrant again this tangent is going to be positive. So you can see that this function is repeating its value after the interval of pi, and therefore it is also a periodic function, but it is repeating its value after the interval of pi. We're not going to require its average value anywhere in physics, so we'll not talk about that. We are going to talk about that situation, what will happen if x is tending to 0. You can see that in this case also this is similar to the case of sine x. So therefore tan x will be nearly equal to x. And in fact we can say that when x is tending to 0, tan x is nearly equal to x, and not just this is also nearly equal to sine of x. So this thing we are going to use very frequently in physics, so you must keep it in your mind that whenever we have a tangent function and the angle is very small, then tan x can be nearly written equal to sine x or simply x. So this is all about the tangent function. Let's now talk about cosecant function. So the cosecant function is y equal to cosec x, or it is simply equal to 1 by sine x. We won't talk much about this function because it is not of much use in physics. So we'll just talk about the domain and range of this function. What is the domain? That means all values that x can take. Well, x can take any value except those values where sine x is going to be 0. Therefore, the domain is going to be r minus all those values. That means 0, pi, 2 pi, and so on, of course plus minus. So we can simply write that the domain of this function is going to be r minus n pi, and of course this n is an integer, so it can take any value, positive, negative, as well as 0. So it becomes domain of this cosecant function. What about range of this function? If you look at the denominator is always less than 1, except that in one situation it is going to be equal to 1. And since the denominator is almost always less than or equal to 1, therefore the overall quantity is definitely going to be greater than 1 or equal to 1 in one situation. And of course this is going to be in the positive side as well as in the negative side, and therefore the range is going to be from minus infinity to minus 1 union from 1 to positive infinity. So this is going to be the range of the cosecant function. We're not talking about the graph. Of course, it is going to be a periodic function, but rest of the things you will talk about in mathematics. So let's skip this part because this is the only thing which we might require in physics. Let's now talk about the secant function. So the secant function is y equal to sec x. This is nothing but equal to 1 by cos x. So what about its domain? Well, any real value except those values where cos x is going to be equal to 0. And we already know that it is going to be 2n plus 1 pi by 2. Therefore, the domain of secant function and tangent function, they are going to be same. Now, as far as the range is concerned, in case of tangent function, it was from minus infinity to plus infinity. However, in the secant function, the range is going to be same as that of the sine function. That means y is going to lie from minus infinity to minus 1, of course, including minus 1. Therefore, we are using this square bracket over here, union 1 to positive infinity. And again, here we're not going to talk about its graph. Of course, it is going to be periodic function. So next we will talk about the cotangent function. So the cotangent function is y equal to cot x, which is nothing but equal to cos x divided by sine of x. So we'll talk about its domain first, that is all values that x can take. We can see that it is going to take any real number except those numbers where sine x is going to be equal to 0. And we know those values. So the domain is going to be range minus n times pi. And this n is an integer, positive, negative, or 0. Now let's talk about the range of this function. Well, range of this function will be same as the range of the tangent function, which is going to be from minus infinity to plus infinity. Now if we talk about tangent function and cotangent function, tan x is basically not defined at x equal to pi by 2. However, cot x is going to be 0. And similarly, cot x is not defined at x equal to 0. However, tan x is going to be 0. Anyways, this is all about all these 6 functions. Now we are going to talk about one special function which is very useful in certain situations in physics. And that function is y equal to sine square x. So what is the domain of this function? The domain of this function is going to be from minus infinity to plus infinity, and the range of this function, that means all values that y can take, it is going to be from 0 to 1. Of course, it cannot be negative, and the maximum sine x can go is 1. Therefore, the maximum value of sine square x is going to be 1. So this is the domain and range of sine square x. Let's have a look at its graph. So this is how the graph of sine square x is going to look like. You can see that there is no negative part of this graph. In fact, the negative part of the sine x has now become positive with a slight difference. What is that difference? Well, we'll talk about the average of this sine square x. There you will see the difference. However, as far as the maximum value is concerned, you can see that maximum value is equal to positive of 1 and minimum value is 0. Therefore, it is also a fluctuating graph, but the fluctuation is happening from 0 to 1. And what will be the period of this function, because this is also a periodic function, because you see the peak is going to be at x equal to pi by 2, and it is again going to be 0 at x equal to pi. So you can see that this graph is repeating its value after an interval of pi. Therefore, it is a periodic function with period equal to pi. Now we will talk about the average of this function. Well, the average of this sine square x in the interval, let's say 0 to pi, this is equal to 1 by 2, and in the interval of 0 to pi by 2, this average is also equal to 1 by 2. And if you take the interval from pi by 2 to pi, it is again going to be equal to 1 by 2. As I said, how we get these values, again we studied in the chapter of integration. So right now, as it is also a quick note, so we just need to get into the final results. We need to memorize them, and we are going to use them while solving the problems. So this is all about your sine square x. Now the last thing that we need to talk about is the function y equal to cos square x. So the domain of this function is going to be from minus infinity to plus infinity. And what about the range? All values that y can take, it is going to be from 0 to 1, just like sine square x function. It is going to be confined between 0 to 1. We have to include the values 0 and 1. And let's have a look at the graph of cos square x, and you can in fact predict that it is going to be like this. All the negative part, they have become positive. And you can see that at x equal to 0, it is going to have its peak Even cos x had its peak at x equal to 0, and again it is repeating its value after x equal to pi. However, in case of cos x, it used to repeat its value after 2 pi. That is because now the negative part has become positive, so therefore it is repeating its value after an interval of pi. So this is also a periodic function with an interval of pi. Now we'll talk about the average of this function. Average of this function in the interval, let's say from 0 to pi, you can see that in the interval from 0 to pi, all are positive and it is going to be equal to 1 by 2. In fact, if you take any other interval, for example, minus pi by 2 to plus pi by 2, it is still going to be equal to 1 by 2. And if you take any other interval, for example, pi by 2 to pi, then in that case also it is going to be 1 by 2. And it is not that you take any interval of pi by 2 or pi, it is going to be 1 by 2. Only those intervals which I said, the average of cos square x is going to be equal to 1 by 2. So this is all about trigonometric functions. Now lastly, we'll quickly talk about sine rule and cosine rule that helps us with triangles. So what is sine rule? Well, let's imagine this triangle, and in this triangle, this angle is alpha, this angle is beta, and this angle is gamma. And opposite to alpha, the side length is A, and opposite to beta, the side length is B, and opposite to gamma, the side length is C. Then according to sine rule, sine of alpha divided by A is equal to sine of beta divided by B is equal to sine of gamma divided by C. So basically we can use this rule in certain situations where, let's say, alpha, beta and A that is given to us, and we have to find the value of B. That means we have been given two angles, alpha and beta, and opposite to either alpha or opposite to beta, one of the side is given to us. Then we can find everything else in this triangle. So this is sine rule. Now let's talk about cosine rule. And now imagine a situation in which we know two sides of this triangle. Let's say this is A and B, and the angle containing the two sides is known to us. Let's say this is theta. And we need to find out everything else in this triangle. For example, let's say we need to find out the side length which is opposite to this angle theta. We need to find out the value of this C. So by using cosine rule, we can find out the value of C in terms of A, B and theta. So according to cosine rule, the C square will be equal to A square plus B square minus 2AB cos of theta. So by using this formula, we can find out the value of C. Once C is known to us, we can now use sine rule in order to find out the other two angles of this triangle. So this is all about the trigonometric functions and the trigonometric identities. And if you want to solve problems specifically related to this topic only, and you do not want to waste your time in finding problems in the books or elsewhere, then you can download my application, whose link is provided in the description box below. Thanks for watching.